Pluto is the coldest world we have ever visited, minus 380 degrees Fahrenheit. Cold enough to freeze the air you breathe, cold enough to turn water ice into stone, and underneath that stone, there is an ocean. Not a pocket, not a damp layer, liquid water, possibly deeper than any ocean on Earth, sitting in absolute darkness beneath tens of miles of frozen shell. Planetary scientists are now close to agreement that it is down there. The problem was never finding it. The problem is explaining why it is still liquid. Every other buried ocean in the outer solar system has an engine. Europa is flexed by Jupiter, Enceladus is squeezed by Saturn. Their host planets pull them out of shape on every orbit, and the friction of that endless kneading heats them from within. Pluto has no host planet. Pluto has no engine. It has a rock core that has been cooling for 4.5 billion years, and a sun that delivers roughly 1,000th of the light that falls on Earth. Run the physics forward, and that ocean freezes solid. Not eventually, long before the first living cell appeared on our own planet. Which leaves two possibilities. Either our models of how worlds cool are wrong, or Pluto is doing something we have never seen any world do. For 10 years, that question has been the quiet center of an argument almost nobody outside the field has heard. On June 2nd, 2025, the argument got stranger. A team led by Tanguy Bertrand, a planetary scientist at the Observatoire de Paris, published results in the journal Nature Astronomy using the James Webb Space Telescope. They had managed something no observatory had achieved in the 95 years since Pluto was found. They separated Pluto's heat from Charon's. Until that paper, every thermal measurement of the Pluto system was a blend. The two bodies orbit each other tightly, and they lie 3 billion miles away, and no instrument could tell which of them a given infrared photon had come from. Every temperature figure in the scientific literature was an average of two different worlds. Webb pulled them apart, wavelength by wavelength, between 15 and 25.5 microns, using an instrument cooled to within a few degrees of absolute zero to keep its own warmth from drowning out the signal it was hunting for. The entire measurement rests on detecting heat from an object where almost none exists, and the result did not tidy anything up. It confirmed that Pluto's atmosphere is running far colder than atmospheric physics allows, and that the reason has nothing to do with the gases in it, which leaves us holding two anomalies at once, pointing in opposite directions, on the same small body at the edge of the solar system, too cold on the outside, too warm on the inside. Keep both of those in your head. By the end of this, only one of them will have an answer that everyone agrees on. For 85 years after its discovery, Pluto was a rumor, not a world, a moving point of light, 3 billion miles out, too small and too distant for any telescope on Earth to resolve into a disk. Astronomers argued for decades about its diameter. We were not certain it even had an atmosphere until 1988, when it drifted in front of a star, and that star's light faded gradually instead of cutting off. Everything else was guesswork wearing the clothes of fact. Textbooks printed it as the 9th planet and moved on. It helps to measure that ignorance against Pluto's own clock. A single orbit takes 248 Earth years, which means that in the 96 years since a 24-year-old spotted it on a photographic plate, Pluto has not completed one circuit of the Sun. It has traveled through roughly a third of its year. The seasons that were underway at the moment of its discovery have not finished. Then, in 2006, two things happened to Pluto within 7 months of each other. In January, a spacecraft the size of a grand piano lifted off from Cape Canaveral. It was called New Horizons, and it left Earth at 36,000 miles per hour, the fastest departure ever achieved, crossing the orbit of the Moon in 9 hours. In August, the International Astronomical Union voted, and the destination of that mission stopped being a planet. The spacecraft flew for 9 years, 3 billion miles. It spent most of the trip asleep. On July 14, 2015, it crossed the Pluto system at more than 30,000 miles per hour and did not stop. No orbital insertion, no braking, no second pass. Everything the human species knows about the surface of Pluto was collected in a window of hours by a machine that was already leaving. It then took roughly 16 months to send that data home, in a trickle, across a gap wide enough that a radio signal needs 4.5 hours to cross it. What came back was not a dead rock. Mountains of water ice standing 2 miles tall. Glaciers of nitrogen moving like the ice sheets of Greenland. More than 20 distinct layers of blue haze stacked into the sky. And a bright, pale plain shaped like a heart, sitting near the equator, on which no impact crater has ever been confirmed. Every question in this video comes from that single afternoon. 3 people carry this story, and not one of them is an astronaut. The first is Clyde Tombaugh, who was 24 years old and had never attended a university. He grew up on a farm in Burdett, Kansas. He had saved for college, and then a hailstorm flattened his family's crops, and the savings went with them. He ground his own telescope mirrors using parts salvaged from farm machinery, made careful drawings of Jupiter and Mars, and mailed them unsolicited to the Lowell Observatory in Arizona, hoping a stranger would open the envelope. They gave him the job nobody wanted. Photograph the same patch of sky on different nights. Then compare the plates through a machine called a blink comparator, star by star, hunting for the one point of light that had shifted. A single field could hold 150,000 stars. 10 months later, he found a planet. Tombaugh spent the rest of his life teaching in New Mexico. He died in 1997. He never saw a photograph of the world he discovered, because no such photograph existed while he was alive. Every image of Pluto in his lifetime was a dot. He returns at the end of this story, and not in the way you would expect. The second name is Shi Zhang, professor of Earth and Planetary Sciences at the University of California, Santa Cruz. In 2017, he published an explanation for Pluto's temperature that most of his colleagues refused to accept. He has since described their reaction without softening it. It was a crazy idea. The third is Francis Nimmo, also at Santa Cruz, whose specialty is a question that sounds impossible on its face. How do you work out the inside of a world you cannot open, cannot land on, and cannot visit again? In 2016, Nimmo answered it for Pluto, without collecting any new data at all. He did it by asking why the heart was in the wrong place. No new instrument, no new mission. A photograph everyone already had, and a question nobody had thought to ask of it. The western lobe of that heart is a basin called Sputnik Planitia. It stretches more than 600 miles from edge to edge. It is filled to the brim with nitrogen ice, and it is almost certainly the scar left by something large striking Pluto early in its history. You could drop the state of Texas into it and have room left over. If it sat on Earth, it would swallow the Mediterranean, and the first thing wrong with it is visible in the photographs. The surface of that basin is carved into pale polygonal tiles, most of them between 6 and 25 miles wide, divided by shallow troughs. They are not craters, they are not erosion, they are convection cells, the fingerprint of a material heated from underneath, rising through the middle, spreading outward, sinking at the edges. The same pattern forms in a pot of soup on a stove, which means the nitrogen ice filling Sputnik Planitia is not frozen still, it is turning over at a few centimeters a year, driven by warmth arriving from below. Models put the full renewal cycle at around 500,000 years. That is why there are no craters. The basin keeps erasing its own history. In a solar system where every ancient surface is pockmarked with 4 billion years of impacts, this one is blank, and something has to be paying the energy bill to keep it that way. But that is the small anomaly. Here is the large one. Sputnik Planitia sits almost exactly on the line connecting Pluto to Charon, nearly on the tidal axis. Out of every location on the surface of a world where a basin might have landed by chance, it occupies one of the few that gravity actually pays attention to. Coincidence is possible. The odds against it are steep. In November 2016, Nimmo and more than 60 co-authors published a paper in Nature arguing that it was no coincidence. Their claim was that the basin did not form where it now sits. It traveled. Over millions of years, the entire outer shell of Pluto rotated, carrying Sputnik Planitia around the globe until it came to rest on the axis. Worlds do this. It is called true polar wander, and it happens when a concentration of extra mass builds up somewhere on the surface. That mass gets tugged toward the tidal axis, and the whole crust reorients around it, the way a ball with a weight glued to one side always settles the same way. Which is where the logic breaks. A basin is a hole, A hole is a shortage of mass, not a surplus. An impact scar should have drifted away from the tidal axis, not toward it. To end up where it is, Sputnik Planitia has to be heavy, and it is a crater, unless something is pushing up beneath it. Liquid water is denser than water ice. If the impact cracked and thinned Pluto's shell at that spot, and if an ocean lay underneath, that ocean would bulge upward into the thinned region, denser material rising closer to the surface. Additional mass, concentrated exactly where the basin is. The nitrogen ice piled on top contributes the rest. Nimmo's team calculated the alternative. Without an ocean, producing enough surplus mass would demand a layer of nitrogen ice more than 40 kilometers deep, which nobody considers plausible. And that is how the ocean was found. No probe, no drill, no photograph of water. It was reasoned out from the position of a bright stain on a map, the same way Neptune was reasoned out from irregularities in the orbit of Uranus before anyone aimed a telescope at it. It is worth being honest about what that means. An inference is not a measurement. In that same issue of Nature, a separate team argued that accumulated nitrogen ice alone could have tipped Pluto over, requiring no ocean. Others have since suggested that the dense core of whatever struck Pluto is still buried down there, supplying the mass instead. Nobody has seen this ocean. What we have is a world behaving as though one is present. And that returns us to the thing that should not be possible. Charon is tidally locked to Pluto. The two turn as a single rigid unit, permanently facing each other, with no flexing and no friction. There is no gas giant nearby. There is almost no sunlight. Pluto's only heat source is radiogenic, the slow decay of radioactive elements in its rocky core, weaker every year for 4.5 billion years. Feed that into a thermal model and the ocean freezes. Not in the distant future, in the distant past. There is a second oddity that any answer has to account for. Pluto's shell is not evenly thick. It is thinner beneath Sputnik Planitia and thicker elsewhere, and it has held that shape for billions of years. A warm, soft shell would have flowed and leveled itself out long ago. The simplest proposal is antifreeze. Dissolve enough ammonia or salt into water, and its freezing point falls sharply, and ammonia is abundant out there. It helps, but nobody has measured how much is down there, and it does nothing to explain the uneven shell, which leaves two explanations that are doing the real work in the field, and they disagree with each other. The first handles both problems in one move. In May 2019, Shunichi Kamata of Hokkaido University, working with Francis Nimmo and researchers at 5 other institutions, published a paper in Nature Geoscience proposing that Pluto's ocean is sealed beneath a layer of gas hydrates. Gas hydrates, also called clathrates, are peculiar materials. Water ice locks itself into microscopic cages and traps gas molecules inside them. They look like ordinary ice. They behave nothing like it. They conduct heat about 5 times more poorly. They are, in effect, insulation. Kamata's team modeled a layer of methane clathrate, roughly 10 kilometers thick, resting at the base of the shell directly above the ocean, with the methane cooked out of organic material in the hot, rocky core below. The difference was decisive. Without that layer, Pluto's shell reaches uniform thickness within about 1 million years, and the ocean freezes out. With it, the shell holds its uneven shape for more than 1 billion years, and the ocean survives to the present day. One thin blanket of trapped gas, holding an ocean above absolute cold across the entire history of the solar system. There is even a chemical clue that fits. If methane is being locked into clathrate cages down there, almost none of it should reach the surface, and Pluto's atmosphere is precisely what that predicts. Rich in nitrogen, strangely poor in methane. The second explanation refuses the question altogether. In 2020, Carver Basin, Francis Nimmo, and Alan Stern, the principal investigator of the New Horizons mission himself, published a paper in Nature Geoscience, arguing that Pluto's ocean was never manufactured by internal heating. It was there from the start. The assumption had always been a cold start. Pluto assembles from frozen debris, stays frozen, and radioactive decay gradually warms the interior until part of it melts. Under that story, the ocean is young and currently at its largest. Bason's team argued the opposite. If Pluto assembled quickly, The raw energy of impact after impact during its formation would have melted it outright. The ocean would be older than the crust covering it, and it has been freezing, slowly and without interruption, ever since. Here is where the argument becomes testable, because water does something almost no other substance does. Water expands when it freezes. A world that starts cold and melts internally contracts. Its surface should show compression, ridges, wrinkles, crust shoved into itself. A world that starts hot and freezes from the outside inward swells. Its surface should show extension, faults pulled open, cracks, terrain stretched apart. New Horizons photographed the answer without anyone asking for it. Pluto's surface shows extension, long troughs and fault systems, some ancient and some more recent, running for hundreds of miles. The models put the total at roughly 0.5% of linear strain across the last 3.5 billion years. What the images do not show is compression. Anywhere. Pluto is not a frozen world that warmed up. It is a warm world that has been freezing for 4.5 billion years and has not finished. Everything to this point has circled one problem. How a world this cold keeps heat in. Now invert it. As New Horizons passed through the system in 2015, it sent radio signals back through Pluto's atmosphere and measured how they bent. Standard theory predicted an upper atmosphere near 100 Kelvin. The instrument reported 70. That is around 30 degrees colder than the physics permitted. In atmospheric science, a 30-degree gap is not a rounding error. It means a component of the model is missing. The obvious candidate was water vapor, which sheds heat efficiently. But the arithmetic collapsed immediately. Cooling Pluto's atmosphere by that much would require water vapor, supersaturated by many orders of magnitude, quantities the atmosphere is physically incapable of holding. Every gas-based explanation failed the same way. In 2017, Shi Zhang, together with Darrell Strobel of Johns Hopkins University and Hiroshi Imanaka, proposed that the coolant was not a gas at all. Pluto has haze. New Horizons photographed it from the far side, backlit by the sun, and those images are among the most beautiful the mission produced. More than 20 separate layers of blue mist, rising hundreds of kilometers. The haze forms when ultraviolet light shatters nitrogen and methane high in the atmosphere, and the fragments recombine into hydrocarbon particles tens of nanometers wide, which then sink, clumping together and growing as they fall. Zhang's argument was that those solid particles, not the gas surrounding them, govern the entire energy budget. They absorb sunlight, they warm, and then they dump that energy straight back into space as infrared radiation, far more efficiently than any gas molecule manages. The haze is not a blanket, it is a radiator. Pluto is refrigerating itself. The title they gave that 2017 paper states the paradox without apology. The haze heats Pluto's atmosphere, and that is precisely why the atmosphere is cold. Every photon those particles catch, they throw away. His colleagues were unconvinced, and he understood why. But he and his co-authors did the one thing that separates a strange idea from a scientific one. They wrote down a way to prove themselves wrong. If the haze is cooling Pluto by radiating heat, then the haze itself has to be glowing in the mid-infrared, brightly enough to detect. And they stated plainly what that detection would require. A telescope bigger and colder than anything then flying. That telescope launched on Christmas Day, 2021. There was still the second obstacle, the one patience could not solve. Pluto and Charon sit close enough together that every instrument capable of sensing their heat had merged them into a single reading. You cannot verify a prediction about Pluto's atmosphere while the heat of a moon is mixed into your data. Webb's primary mirror is 21 feet across. Its mid-infrared instrument finally did what nothing before it could. It told the two apart. Bertrand's team built separate thermal light curves for Pluto and for Charon. The haze was there, glowing in the mid-infrared, exactly where the 2017 paper said it would be. The measurements showed it is built from Titan-like organic particles, along with hydrocarbon and nitrile ices, and that it largely controls the heat balance of the atmosphere. 8 years after his colleagues called it a crazy idea, Shi Zhang was right, and he was not alone. The same observations tested a second prediction, made in 2023 by Linfeng Wan, a former doctoral student of Zhang's. about how much Charon's brightness should vary as it rotates. That one held as well. 2 predictions, both written down years before the instrument existed to check them, both confirmed in a single campaign. This is what science looks like when it functions. A claim published in advance, phrased precisely enough to be destroyed, waiting years for the evidence to arrive. The picture that emerges is unlike anywhere else we have looked. Pluto is the only body known where the atmospheric energy budget is governed by solid particles instead of gas. Its air obeys rules that apply nowhere else in the solar system. Webb turned up something further in the same campaign. Material is escaping Pluto's atmosphere and settling onto Charon, freezing onto the moon's poles through winters that last decades. 2 worlds exchanging atmosphere across the vacuum between them. Nothing else in the solar system does that either. Before we go outward, stand on it for a moment. The sun is up. You can find it without effort. It is by far the brightest object in the sky, a single hard point of light, too small to show a disk. It gives you roughly the light of twilight on Earth, and no warmth at all. It will never climb higher than that. The sky is not black and it is not blue. It is a permanent blue-grey dusk, the color of the haze, and it never clears and never darkens. Under your boots the ground is water ice, and at 380 degrees below zero, water ice is neither slippery nor brittle. It is structural. It behaves like rock. Strike it and it would ring. The air around you is roughly 100,000 times thinner than air at sea level. The cold would take you long before you understood what was happening. And overhead, filling a piece of sky 7 times wider than the full moon appears from Earth, is Charon. It does not move, it does not rise, and it does not set. It hangs in one fixed position over one fixed hemisphere, and it has hung there for billions of years. Half of Pluto has never seen it. The other half has never stopped seeing it. Now look down, beneath the frost, beneath the ringing ice, beneath tens of miles of shell, there is liquid water in absolute darkness. It has been there since before the Earth had oceans of its own. And that single fact quietly dismantles the idea that has organized the search for life for the last 60 years. The habitable zone. The band of orbits around a star where a planet receives the right amount of warmth for liquid water to survive on its surface. Earth is in it. Mars is at the cold edge of it. Venus is at the hot edge. Pluto is 3 billion miles outside it. And Pluto may have an ocean. If Basin's team is correct that Pluto was born hot, then the same accounting applies outward, to Eris and Makemake, and the hundreds of thousands of icy bodies drifting through the Kuiper belt. Many of them could have formed with liquid water inside, which would mean the ocean is not the exception in this solar system. The exposed ocean is. Earth may be the strange one, wearing its water on the outside where a star can see it. That is the reframe hiding inside a story about a dwarf planet, and it changes what counts as a promising target. Telescopes are aimed at planets orbiting other suns at the correct distance for surface water. Every one of those searches assumes a star is the thing keeping the water liquid. Pluto suggests that a star may be optional. A rock core with enough radioactive material, a shell thick enough to trap what escapes, and time that appears to be sufficient. And rock, ice and time are the 3 most common things in the universe. It should be paired with an honest limit. The reddish-brown material staining Pluto's surface is not soil, and it is not life. Those are tholins, haze particles built from nitrogen and methane by ultraviolet light, sinking out of the sky and settling on the ice for as long as Pluto has had an atmosphere. Complex organic compounds, the same family of molecules that rained onto the early Earth before anything here was alive. They are the chemistry that preceded life. They are not evidence of it. Nobody has found life on Pluto. Nobody has claimed to. What sits down there is a set of conditions that on Earth we would call habitable, in a place where nothing has ever arrived to test whether it is. And the deepest connection is not about aliens at all. Before oxygen filled our own atmosphere, more than 2.4 billion years ago, the early Earth may have been wrapped in a hydrocarbon haze of the same kind, thicker, chemically similar. Life was already here, living underneath it. The mechanism now freezing Pluto may be the same mechanism that once shaded the world where we began. Here is the part that never makes the headlines. That ocean is losing. Radiogenic heat cannot be renewed. The radioactive elements in Pluto's core have been decaying since the solar system assembled itself, and there are fewer of them every year. A clathrate cap slows the loss. Antifreeze lowers the threshold. Neither adds a single joule. They buy time and nothing else. We did not discover a warm world at the edge of the solar system. We arrived once, for a few hours in 2015, in time to photograph something that has been ending for 4.5 billion years. There is no funded mission to return. No orbiter, no lander, no launch date. The distances are too great and human careers are too short, and space agencies choose targets that produce answers within a working lifetime. The James Webb Space Telescope is now the only instrument capable of studying Pluto in any detail, and it is doing that from 3 billion miles away. New Horizons is still flying. It passed Pluto, past Arrokoth, and continues outward toward the edge of the solar system. It will never come back. Bolted to the inside of its upper deck is an aluminium canister, 2 inches wide and half an inch tall, holding 1 ounce of ashes. Before he died in 1997, Clyde Tombaugh asked to be sent into space. And that is how the farm boy who lost his college money to a hailstorm, who built telescopes out of scrap metal and found a planet by staring at photographic plates until a single dot moved, flew past his own discovery on July 14, 2015, 18 years after his death. The inscription that Alan Stern wrote for that canister closes with a line of Latin, "To the stars, through difficulties." He never knew there was an ocean underneath. Neither did anyone else, until somebody noticed that a heart-shaped stain was sitting in the wrong place on a map. We call the outer solar system dead because the word is comfortable. It lets us believe that everything worth knowing happens near a star, and that the dark between the stars is empty. The dark is not empty, it is patient. It holds warmth for an enormous stretch of time and then releases it. And the only reason Pluto looks frozen to us is that we showed up near the end of a process we have never had the lifespan to watch. We did not find a dead world, we found a slow one. Thanks for watching, and I'll see you in the next one.